we're going to start doing the unit circle. Does everybody know why it's called the unit circle? Does everybody remember why it's called the unit circle? You listen? You know, Vinny? The radius is 1 unit. Right? 1 unit. So it's called the unit circle. There we go. So we have graphed some circles in here the past couple chapters. X squared plus y squared is radius squared. That's the equation of a circle. In a circle, I've drawn one. Here is the radius, or a radius, from that circle. And at the end of that radius, well, at the start of the radius is the ordered pair 0, 0. And at the end of that radius is some ordered pair xy. To get to that ordered pair xy, I'm going to draw it bigger so I can write bigger. To get to that ordered pair xy from 0, 0, I will start at 0, 0, and I will go to the right. How far? X, and then I will go straight up from there, making a 90 degree. Straight up, how far? Y. So the length of this horizontal part of the triangle is x long. The length of the vertical part is y long. How do we find the length of the radius? What did I just write? Pythagorean theorem. So how do I find the length of radius? I do x squared plus y squared equals r squared, square root it, and we get the radius is r. Excuse me. So all of that is described on your paper in that section right there. One thing that people make mistakes on is when we talk about finding sine, cosine, and tangent of a triangle like this, they don't put theta in the correct place. The theta has to be right there at the origin. It has to connect to the x-axis and the radius. It has to be between x and r. It has to be. You put it somewhere else, you get the wrong answers. And then using that information, we have trigonometric ratios of theta in like formulas, where the sine, instead of thinking that it is opposite over hypotenuse, we can memorize it is y over r. It is the y value of the ordered pair over the radius. The cosine is x over r. The tangent is y over x. Cosecant is r over y. Secant is r over x. Cotangent is x over y. Now, we have a unit circle with a radius of 1. If I know that the r is 1, I can take these formulas and make them even simpler. So instead of saying the sine of theta is y over r, I'm just going to say the sine of theta is y over 1. So sine of theta is y. Sounds weird, but like I always say the sine is y, and I make the weird noise with my mouth because that's how we remember that the sine is y. How are you going to know that the sine is y and the cosine is x? I don't know. You just got to make up something. So come up with a way so that you know the sine is y, okay? And the cosine is x. Okay? So what's cosine? I already said it. Okay. And then the tangent is y over x. So if I go in order, sine, then cosine, the tangent is just those two on top of each other, sine and cosine. Now, you may have done this last year. I know that at least 3 of the teachers did it last year. I don't know about all of them, but we talked about how if the tangent is y over x, and y is the sine of theta, and x is the cosine of theta, you can say that the tangent of theta is the sine of theta over the cosine of theta. Or you can say tangent is y over x. Whatever makes sense in the way you're using it. But I wanted to show you that now, because we will use it eventually. For the other three, they're just the reciprocals of the first three. So we can go up to the top and replace r with 1, and for cosecant you get 1 over y. Or, just look right here, and what's the reciprocal of y? 1 over y. Secant is 1 over x. Cotangent, we reciprocate tangent, x over y. Which is also the cosine of theta over the sine of theta. My very first example did not make it on the notes, somehow magically just tripped out. So, on the back of this, might be a good spot to put it. It's just going to be one example that didn't make it. Oh, I forgot. There's going to be an example. I forgot it's after this. So, when we talk about reference angles, this is just vocabulary. When we talk about reference angles, the reference angle is what you will use to determine the sine, cosine, and tangent of the angle. The reference angle is only an acute angle between 0 and 90 degrees. In each quadrant, it's acute. So if I'm all the way over here in the second quadrant, I'm not going to use this obtuse angle. I'm going to use the acute angle, and it always connects the radius and the x-axis, always. So down here it does say the reference angle is always positive and it's acute. So it's between 0 and 90. It's always positive and it's acute. You'll never tell me a negative reference angle. You'll never tell me an obtuse reference angle. Positive and acute. And then it's formed by the radius and the x-axis. If you form it a different way, you get it all wrong. So that vocabulary is pretty important. All right, so this example that didn't make it on there says, determine the exact values of the 6 trigonometric functions of the angle theta. Did they give us the angle? They did not. What did they give us? Christian, what did they give us? What is that? Oh, it's on your paper, girl. Can you sit closer? Oh, yeah, it's not on your paper. Like, can you sit closer? So, Christian, what is that thing that I just put on your paper? An ordered pair. The coordinate would be like x by itself or y by itself. Ordered pair would be the 2 coordinates together. I'm going to draw that coordinate. Let's go find it. What quadrant is that coordinate in, so I don't have to like draw too much here? How do you know it's in 1? They're both positive, right? Okay. I'll just draw quadrant 1 kind of. 12/13 is a little bit more than double 5/13, so I'm just going to approximate 12/13, 5/13. Well, that's good. And I'll put the 12/13, 5/13 there. Okay. Well, what I've done is I formed a triangle. Where is my theta? Where is my reference angle going to be located always and forever? Between the x-axis and the radius, right there. X-axis and the radius, that's where theta has to be. And then I need to know the side lengths. So if I start at the origin and I go to the right, I am going x far. I'm going 12/13. And I start at the end of that and I go straight up and I'm going 5/13. That's my y. How do I find my radius? What do I need to do? X squared plus y squared, the Pythagorean theorem, and then square root it. So I would go through that to find the answer, but I also recognize that this one is a triple. And if you've learned triples in the past, you may save yourself a little bit of time. This is a 5, 12, 13 triple. Here's a list of some triples we looked at last class. 5, 12, 13 triple, do you see the 5 and the 12 where they're located? So those are the two sides. The hypotenuse should be 13, but this has a shrink on it. What's my hypotenuse going to be if my sides are 5 and 12, but now they're 5/13 and 12/13? What's my hypotenuse going to be following that pattern? There should be 1, 13/13, right? Or if you did your Pythagorean theorem, you still get 1. Now, every time I write sine theta, cosine theta, tangent theta, I'm writing theta because I need to have it memorized that sine is always of an angle. So I don't mess stuff up later because I forget that. So I'm not taking shortcuts and just writing sine. I'm writing sine of theta every time. And then the sine is either y over r, or if it's the unit circle, y. What's the answer for y? For y over r? 5/13. This is the unit circle because the radius is 1. But if you still did 5/13 over 1, you get 5/13. Cosine is x over r. So cosine is 12/13. Tangent is y over x. So I'm going to have to do 5/13 divided by 12/13. Now we're going to have to do this, these kind of fractions, these rational expressions later, but it's going to be all cosines and tangents and stuff later. So you need to know how to do this by hand and not be typing in your calculator right now. Because when I throw cosine x and sine thetas and all in there, you're not going to be able to type in your calculator. So think about this. If we're taking 5/13 and we divide it by 12/13, what's the same thing as dividing? Multiply by reciprocal. So instead, I'm going to do 5/13 and multiply it by the reciprocal of 12/13. 13 over 12. And we multiply fractions straight across. So straight across. And if the top and the bottom both have a factor that is the same, we can cancel that factor. As long as there's no plus or minus signs in there, we can cancel those 13s. 5/12. And then from there, how do I get the other 3? Reciprocate. Doesn't go fast. Okay. All right, the next example is the same as mine. There's got to be like a T in it. The T, don't be afraid of a different symbol. It's just theta. It's just theta. It's the bottom of the regular page that we started on. It's just theta. So it's asking for the 6 trigonometric functions at theta being pi over 6. So step 1, draw the picture. Step 1, draw the picture. The majority of us are visual people. We need to see it. And if this one's not that hard, but they will get more challenging. So pi over 6. I start at 0, and I'm going to rotate to pi over 6. So I need to know where pi is. Pi is the 180 degree. And I'm dividing this top half pi into how many equal sections? 6 equal sections. And I only need one of them. So my theta is connecting the x-axis and the radius. So that's where theta is. And then I have to know what kind of triangle it is. And if I'm doing this by hand, it's got to be a special triangle. So pi over 6 is what degrees? If I take 180 degrees, divide it into 6 equal places, pi over 6 is 30. So I know this is a 30 degree, 30, 60, 90, but the theta is at 30 degrees. So we're doing sine of pi over 6. and the other 5 ones too. If you don't have them memorized yet, you are going over here and you're saying across from 30 degrees is which side? The shortest side is across from 30. Across from 30 is the 1. And then across from 60 is the radical 3. And then the hypotenuse is 2. But this is a unit circle, so we have to make the hypotenuse 1. So you have to divide it by 2. And if you divide that one by 2, you can divide all of them by 2. And by then, you just should have just memorized the dang thing. Okay? But it's not memorized yet for most of us, right? So I drew it today, but I'm not using the triangles values. I just know that the sine of pi over 6 is the same as sine of 30 degrees, which Andrew is half. So I didn't even need to look at my triangle. But if you are looking at your triangle, sine is y. Cosine is x, radical 3 over 2. Tangent is y over x. So if you don't have that memorized, now you have to put y over x, which are fractions, and then you have to, instead of divide by the fraction, you have to multiply by its reciprocal, and by all of that time, you could have just memorized that it's square root of 3 over 3. Okay, so we're going to do the memorization in here, aren't we? Yay! All right. Cosecant, I'm just flipping each of these now. So this is 2. That one is flip it and rationalize it, but I have it memorized, so I don't have to do that part anymore because I already have it memorized. And then flip this one, rationalize it, and I have it memorized, square root of 3. Okay? Next example, I'll flip the page in a second, but what should you do first? Okay, let's see. Went downhill big time this week. Anybody else? Anybody else have Aaron Rodgers? No. And I had another guy, 2 other guys that were out. Okay, anyway. What should we do first? Draw. Thank you. Draw. I'm going to draw this one. Here's pi. Pi is half the circle. What are we dividing pi by? What's pi being divided by? 4. It's divided by 4. So on the top half, I've divided it into 4 equal places. 1, 2, 3, 4. But the top number is how many I'm using. So I'm using how many? 5 of them. I got to keep going. I'm going to end up in the 3rd quadrant. So my triangle is in the 3rd quadrant. My reference angle is between the radius and the x-axis. It is acute, so maybe like between 0 and 90, and it is positive. What is my theta? My referencing. What is it? It is in degree form. This is radian, so I am totally going to think about it in degree form, but what is it as a radian? Because we would have to answer that at some point. What would be our reference angle in radians? Pi over 4, right. But I'm totally going to think about that being 45 degrees. Totally thinking it that way because I know what the sine, cosine, and tangent of 45 degrees are because I memorized that. But if you don't have it memorized, you're going to have to go draw your sides. 1, 1, square root 2. But the hypotenuse has to be 1 in the unit circle, so we have to divide everything by the hypotenuse. Square root 2, divide by square root 2, divide by square root 2. And you have to rationalize it, but I've already done that in my head. I already have it memorized, so I'm not going to write it here. And then there's one more thing about this one that's kind of different than the very first one we did. The first one we did was in the 1st quadrant. This one's in the 3rd quadrant. So what do we know about x and y in the 3rd quadrant? Negative. In the 3rd quadrant, x and y are negative. So I got to keep that in mind when I do my sine, cosine, tangent stuff. I'm going to start writing that. So we're doing sine of 5 pi over 4. Now, in the third quadrant, both x and y are negative. So when I'm looking here and I know sine is y and I know cosine is x, what do I know about their values? If it's in the third quadrant, those are going to be negative answers. Now, other than knowing that they're negative answers, that is the only thing that I need by this being in the third quadrant. Other than that, if I know what the sine of 45 degrees is, I don't even have to look at this picture anymore. What is the sine of 45 degrees? Does anybody know? Radical 2 over 2. So this one's going to be negative radical 2 over 2 because it's in the third quadrant. Cosine of 45 degrees, also radical 2 over 2. So also negative radical 2 over 2. The tangent is y over x. Does anybody know the tangent of 45 degrees? That is 1. It's 1 because you put the x over the, or the y over the x. But if I put y, which is negative radical 2 over 2, over x, which is negative radical 2 over 2, do I get positive or negative 1? Positive. If they're both negative, I still get positive 1 there. Then when I go reciprocate everything, if it's negative to begin with, when I reciprocate it, it's still negative. So this one will be negative square root 2, negative square root 2, and then positive 1. The most time you will spend on this is if you do not have 45 degrees memorized as radical 2 over 2, or 1. That's the most time you're going to spend on it if you don't have them memorized. Let's get them memorized. All right, next one on the back. What should we do first? Draw it. Thank you. Correct answer. Oh, but where's 0? Is that in degrees or radians? It is in radians. Why? The over degree symbol. Exactly. Doesn't matter though. Doesn't matter if it's in degrees or radians for 0. Nah. Okay. But it is in radians. So 0 would be, we do have a circle, even though I didn't draw it, we do have a circle. 0 would be that our initial side and our terminal side are in the same place. So we don't even like rotate anything. It's just this straight line out on the x-axis. If it is on the x or the y-axis, you will not have a reference angle because it's not between 0 and 90. It is either 0 or 90. So what we have to do is we have to use the ordered pair. So from the origin, I would go out 0 or out 1 and up 0. That ordered pair is 1, 0. That is called a quadrantal angle. The 0 or 90 degrees would be called a quadrantal angle. It's right on the axis. It's not in a quadrant. Okay, so then I have to find sine, cosine, and tangent, and then reciprocate them. For sine, cosine, and tangent, since we have a unit circle, we use that sine is, which is sine? Sine is y. Just say it weird. And so what is y? At this ordered pair. 0. Cosine is x. What is x? 1. And tangent is y over x. So we put y over x. We put sine over cosine. We get 0 over 1. Is 0 over 1 possible? Yes, it is. It is 0. When is it not possible? When you have a number over 0, you say no. So cosecant of 0 is the reciprocal of y. It's 1 over y. What is the reciprocal of 0? 1 over undefined. Thank you. That would be a big fat no. But don't write no, write undefined. Secant is 1 reciprocated, so just 1. And tangent is 0 reciprocated, which is undefined. How about pi? What should we do first? Draw it. Find where pi is. Ooh, that's right on the axis. That's right on it. What's a quadrantal? I need an ordered pair. When it's quadrantal, I need the ordered pair. Negative 1, 0. Sine of pi is y. Sine is y. What is y? 0. Thank you. Cosine is what? You guys, you know, when you say things, you remember better. Cosine is the x. So cosine of pi is negative 1. Tangent is what over what? Y over x. If you look, it's y over x. It's those two on top of each other. So we do y over x, we get 0. Then we reciprocate them over here, undefined. What else do I reciprocate? Negative 1? Negative. And then undefined. Before we do the next example, I have just a like something that's not in there, and I know we're going to do it at a different date, but I'm just going to introduce it right now. And you probably saw this in a previous course, maybe. So I know people have all day. There's space to do it over, like here. There's plenty of space to draw this right here. So what I'm doing is just writing the ordered pairs and what's negative and positive in each quadrant. So like in quadrant 1, plus, because they're both positive. In quadrant 2, x is negative, y is positive. You guys already know that, right? Yeah. And then when we talk about sine, cosine, and tangent, and you don't have to write this, I'm just writing it. It's already on your paper somewhere. You don't have to write what I'm writing right now. Just thinking about this. When we talk about sine being y, cosine being x, and tangent being y over x, look up here, and where is y positive? Elijah, where's y positive? What quadrants? And where's the y values positive? Quadrant 1 and quadrant 2. Just anywhere you go like this is y is positive. So here, y is positive. So I know that sine, and I'm writing it down this way on purpose. If you know what I'm doing, I'm writing it down on purpose. Sine is positive in quadrant 2. Cosine is x. Where is cosine? X. Positive. Katie.
1 and 4.
1 and 4. And tangent is y over x. And to put y over x, we either have a, to get a positive, my question is where is it positive? We would have a positive over a positive, or negative over a negative. So Seth, where is tangent, which both are positive or both are negative? Where is tangent positive? And 3. Now, all of them are positive in quadrant 1 because we only have positive numbers in quadrant 1. But when you look at the other 3 quadrants, only one ratio is positive in each of those. So there's like a, I don't remember what these things are called, but we like have, just like PEMDAS, please excuse my dear info. There's like one of those, what are those things called, English people? Is it? No. Wait, say it again. Acronym. It's an acronym. Does an acronym only stand for like the real word, or it can stand for other words?
CIA.
Yeah, but it stands for like Central Intelligence Agency or something, right? But this stands for something else. But anyway, yeah, acronym-ish type thing. ASTC, if you want to remember it, the saying is all students take calculus. So if you'd like to remember A, all, sine, tangent, cosine, you say, all students take calculus. Then you know which one's positive in which quadrant. That only works for sine, cosine, and tangent. What would I do for cosecant? What's cosecant the same as? Sine, cosine, and tangent. What's cosecant the same as? Charlie, what's cosecant? Reciprocal of sine. So wherever sine is positive, and you flip it, cosecant would be positive also. So these are like the main ones. And if you use their reciprocals, they go with them. Okay, so evaluate the 6 trig functions at theta being negative pi over 3. Draw it. This is negative. Oh no, a negative number. What does a negative number mean when it's theta? Just goes the other way, clockwise. So instead of going positive pi, we're doing negative pi divided by 3. So the bottom half divided into 3 equal sections. If you want to think about degrees, if I take 180 divided by 3, what's one section? 60. So we got like a 60-degree angle down here. Theta connects the x-axis to the radius. And that would be 60 degrees. The reference angle would be pi over 3. But in degrees, 60 degrees. I think about it in degrees, but like if your question was what's the reference angle, you would say pi over 3. Why can't I say negative pi over 3? What do I mean? Because it's got to be positive. It's got to be between 0 and 90, or 0 and pi over 2. Okay? What do I do? Okay, if you're still using the triangle, this is a 30, 60, 90. The short side is on top, so that would be 1 on top, or the x. And then we would go down radical 3, which would make it be negative. And then the hypotenuse would be 2, but you can't have 2 in the unit circle, so you got to divide everything by 2. And who wants to do that? Let's just memorize them. So sine of negative pi over 3 cosine, negative pi over 3 tangent, negative pi over 3. So my reference angle is 60. It's in the 4th quadrant. What's going to be positive in the 4th quadrant? All students take calculus. Cosine is positive. So that tells me sine is negative, tangent is negative. Because only cosine is positive in the 4th quadrant. Now I just have to answer the question, what's the sine of 60 degrees? What's the sine of 30 degrees? Half. So what's the sine of 60 degrees? It's the other one. Square root of 3 over 2. So what's the cosine of pi over 3? And tangent of 60 degrees is radical 3. And we reciprocate them, we find the other ones. Cosecant negative 2 radical 3 over 3. Secant is 2, and then cotangent is negative radical 3 over 3. All right, how about A? The next day. What should we do first? What should we do? Draw it. We've got a circle, a unit circle, and we have to rotate that terminal side around 13 pi over 6. I'm going to start thinking about 13 pi over 6 being close to something pi over 6 that divides evenly. What pi over 6 divides evenly? 12 pi over 6. So if that's close to 12 pi over 6, it's just 12 pi over 6 plus 1 more pi over 6. Right? Where is 12 pi over 6? What's 12 pi over 6? Say it! Ready? 2 pi. So I'm going to rotate around all the way around to 2 pi, and then I'm going to go pi over 6 more. What quadrant am I in? First quadrant. So when I go to find sine, cosine, and tangent, what's negative in the first quadrant? What's positive in the first quadrant? All of them. So we don't have any negatives. Pi over 6. So I don't have to worry about any negatives. I can just think about the reference angle. So we went all the way around 2 pi, and then we went pi over 6 more. That's my reference angle, but I don't have it memorized as pi over 6. I have it in degrees. So what is pi over 6 as degrees? 30 degrees. Excellent. What's the sine of 30 degrees? Half. So then what's the other one? What's cosine of 30 degrees? Square root of 3 over 2. And then tangent of 30 degrees is 1 with all the 3's. Square root of 3 over 3. Okay? We're not going to do example B. We're going to skip ahead to the calculator question. So if you don't have your calculator out, go ahead and grab that out. And you can go ahead and try question A. Do not say it out loud. Do not give your partner the question or the answer. I'm going to put my answer up, and I want you to check your answer with my answer when you get it typed in your calculator. We have done this before, kind of. Now, if you don't get the same answer, mine's on the calculator, if you don't get the same answer, you have to ask yourself, why didn't I get the same answer? If I not get the same answer, you know why. What do you have to consider every time you type in sine, cosine, or tangent on your calculator set? Am I typing in a degree or am I typing in a radian? And when you see pi over 3 with no degree symbol, you've got to be in radian mode. So if you're not in radian mode, you got the wrong answer, didn't you? Now on, are you in radian mode? Oh, you converted it to degrees, and that's totally fine too. But on the next one, you won't be able to convert it. Totally fine though. What was I saying? I lost my train of thought. Oh yeah, on the test, if you got whatever your answer was, like 0.06 or something, whatever that other answer was before you converted it, you got that. If you got that decimal on the test, how would you really know if you had the wrong answer if you just looked at the decimal? You probably wouldn't, and that's where I saw a lot of mistakes last year. People just being in the wrong mode. So make sure you were thinking about that when you type it in your calculator. So rounding to 4 decimals, 1.7321. So the next one is cotangent 1. Is that degrees or radians? Drew, B, cotangent 1, degrees or radians? How do you know? No degree symbol, so it's radians. How do I type in cotangent though? Nope, no second. No second. Because if you do second, you're actually finding degrees or radian answers. And we already know what the degree or radian is. So you can't type in second. What are you going to do, Christian? Yeah, you have to make cotangent into tangent. So we change cotangent into 1 over tangent. And then put that 1 on the bottom with it. So be careful with that. You should get 0.6421. 0.6421. So this is something that you get better at knowing what to do when you do your homework and you practice thoughtfully. So it's very important that you are practicing this. Cosine 45 degrees. How do we type in that? We're in radian mode. How do we type in 45 degrees? I can create the 3 different answers to what I'm asking. How can we type in cosine 45 degrees now? Nicole? You can change your mode. That's one way. You know there's a way without changing the mode? Let's see, what would you do without changing the mode? Cosine pi over 4, because pi over 4 is 45. So that would be a second way, is you could leave it in your radian mode and type in the radian version of 45 degrees. If it's an easy one, it doesn't take long. There is one more way. I'm in radian mode. And my calculator, I'm in radian mode. Wait, come on. I'm in radian mode right now. But if I tell my calculator that this is degrees, it works. I'm in radian mode, but I typed the degree symbol, and it will give you the right answer. So if you don't type in just 45, you just leave it in radian mode, type in 45 degrees, you're good. So 0.7071. In any of those methods is totally fine with me, whatever one you choose. And the last one is secant 1.8. You have to decide what is 1.8. Is that degrees or radians? That's radians. And then secant we can't type in, so what do we type in instead? 1 over cosine 1.8, approximately negative 4.4 something. I'm still doing it. Negative 4.4014. Okay? Overall, biggest thing that I wanted you to learn today, do you know what it is? What? Memorize it. That's what I want you to learn today. I should memorize that. That's a good idea. Because the faster you have it memorized, the less time it's going to take. Your assignment is all odds. Why would I give you all odds? So you can check your answers. Is that so you can just write them all down and get them right? No. I'm not going to help you when you don't know you won't remember what to do on a quiz or test. That's so you can check them and make sure they're all right. But if you got it wrong, go back and think about what you did and figure out the right way of doing it. I have put all of that on Canvas. I have book pages on there.